you can see you're going to get equations about area, sine, and cosine rules. What they give you is this triangle. They'll not actually give you, but you're supposed to draw it yourself. What it says is that if I have a triangle with corners A, B, and C, I can also get the sides. I'm sure you know this by now. A side that is opposite to A, to angle A, is small letter A. A side that is opposite to B, small letter B, and so is a side that is opposite to angle C, that will be small letter C. Okay, so sine rule says to us that A over sine of the angle A will be exactly equal to B over sine of angle B. So if I know three of those things, I can find the other one that I don't know. Same applies to C. So if I know anything about this and that, I can use that relationship to find the missing part. Okay, and then this is the cosine rule, which says to us that I can find the missing side by using the other sides and the angle that is opposite to that side. It will make sense once you see the triangle. And then the area rule as well, you'll use this also in Euclidean geometry. It says I can find the area of any triangle that is ABC, even if it's not ABC, by just taking the half of two sides and then the sine of the angle that is not actually included as a side. So AB sine C, or I can say BC sine A. Moving on, we have the equations that you'll get for trig identities for grade 12. Not the same as what you'll get in grade 11. So in grade 12, we introduce new trig identities for a compound angle. So our compound angle identities say that the sine of any angle plus any other angle will give you the sine of the first angle, cosine of the second angle, plus, so what you just need to pay attention on is that there's a plus for every plus in sine. Then you get cos alpha sine beta, and then for minus you also have a minus in between. But then for cosine, if you have a plus, then it has to be a minus in between, and it's cos alpha cos beta minus sine alpha sine beta. If it's a negative, then in between it's going to be a positive. Okay, then you have a double angle identity, and you have for cosine you have three choices that you can have. My advice is that be smart on this one. You can choose either and all of them will work, but some of them will take you ages to actually arrive at the answer, or you'll not arrive at the answer at all. So be smart about your choice here. But for sine, you don't even have to ask questions. It's just one identity. So sine 2 alpha is equal to 2 sine alpha multiplied by cos alpha. Okay, then moving on, before we actually do questions, we have the reduction formula. We'll revisit this as we do the questions for everyone to actually see how this is applied. But what we basically have is a cast diagram which says between 0 degrees and 90, you have all trig ratios positive. That is when the angle is smallest. And then between 180 degrees and 90, we take 180 and we minus the angle theta, and there only sine will be positive. We call that the second quadrant. After that, the third quadrant is where tan will be positive, and that's 180 degrees plus theta. Then the fourth quadrant here, 360 minus theta, because we have 360 here. So going down, we are subtracting the theta, and we can even have a negative of an angle. So if I'm going below, it means I'm also taking 0 and subtracting this theta. So just negative theta. And there, only cosine is positive. The rest of them are negative. And then whenever we do 90 degrees, we have what we call cofunctions. So sine of 90 degrees minus theta will become a positive cos theta, and so is sine of 90 degrees plus theta will become a cos theta. So what you have here is that 90 degrees minus theta, this will fall in the first quadrant because we are taking 90 and we are minusing theta. And also 90 degrees plus theta. So we go from 90 and we go in this quadrant, second quadrant, and the sign is positive in the second quadrant. So it will become a positive cos as well. So never confuse that with a negative cos. It will become a positive cos because the parent, which is sine, is positive in the second quadrant. Then if we have cos 90 minus theta, that's also the first quadrant. And because cos is positive as the parent, also sine is positive there. And then 90 degrees plus theta, this one falls in the second quadrant. And because the parent cos is negative in the second quadrant, then it will form a negative sine theta. So this one will follow the parent. It will not follow the quadrant itself for cofunctions. Okay, so that is everything to do with 90 degrees. 270 degrees, we never use it. So we can only use 180 minus or plus, and we can use 360 minus or a negative angle, and then we can use 90 degrees. But remember, when you use 90 degrees, then you go and do your cofunctions. A sine will turn into a cos will turn into a sine. Okay, we'll revisit this as we do examples, and that's exactly what we are going into. So what I have here, I also sent in the group. It's a previous question paper from KZN last year for the June exam, paper 2. And it was question 3, but we'll do all the way to the end of trigonometry. I think it'll go up to, if I show you here, question 4, which is 3D trigonometry, and question 5, which is trigonometric graphs, and that's it. Yes, so for you to be ready for the June exam, you need to master trig graphs, you need to master 3D trigonometry, you need to master the identities, and also this triangle thingy you should know by now. So guys, if you have any question, just raise up your hand. There's a button that raises your hand, and then I'll let you talk. But just stop me anytime you wish to. If I'm going fast as well, just go ahead and let me know, and then I'll slow down. Okay, so the question reads as follows. Question 3, and then in bold and capital letters they say, do not use a calculator when answering question 3. That's the number 1 rule on this one. Very large letters, very much bold. Do not use a calculator in any of these questions you see under question 3. Okay, but for large parts of this, you don't use a calculator, because if you do and you don't know what you're doing, then you're going to lose a lot of marks. Okay, so 3.1 says in the diagram below, P, as you see it there, is in the first quadrant. You remember we did the quadrants, so P is in the first quadrant, and we know that all trig ratios are positive there, such that 5 cos theta is equal to 3. I'll highlight that. R, which is made up of the coordinates K and 6, is a point in the second quadrant, such that angle POR is equal to 90 degrees. Here is POR, so the angle is basically there in the middle, and we can see it's 90 degrees due to the marking that they have there. Okay, then they say determine the value of the following. 3.1.1 tan theta. So what is the value of tan theta? What do we do when we get to a question like this? And this will work for all triangle or for all question 3 Cartesian plane question. What you need to do is to construct a right angle triangle on any point that is given to you. So you can see I'm given this length here, and then it goes all the way to point P. What I'm gonna do is I'm gonna complete a triangle such that it makes a 90 degrees with the x-axis. Makes a 90 degrees with the x-axis. I'll take that triangle and I'll actually draw it right here so that everyone can be able to see it. So I have a triangle like this. So let me complete that. And then I just need one more side. Okay, there we go. And then I know that this triangle is a right angled triangle, which means it has a 90 degrees there. And the angle is theta. You can see it is shown. Then this is P right here on the point. They gave us this value here highlighted in yellow, that cos theta, which is our angle inside the triangle, is equal to 3/5. So if I take that and change it to make cos theta the subject, then I get 3/5. So I just divide by 5 both sides. This is what I'm looking for. What this tells me is I can go and refer to SOHCAHTOA. Remember SOHCAHTOA, and this will tell me that sine is given by opposite over hypotenuse, cosine is given by adjacent over hypotenuse, and tangent is given by opposite over adjacent. So it means because I have cosine already defined here for me in the question, I just need to focus on the cosine part. Okay, so this will work for any of these questions if you follow the procedure here. So this tells me that with respect to the angle theta, I have cosine of theta equal to adjacent of angle theta over hypotenuse. If you look at our triangle here, the adjacent side is actually the side here, which is along the x-axis. So that will be 3 because it's adjacent and it's on top. The hypotenuse, which is on the bottom, will be the longest side on our triangle, and that will be 5. So then if I define, or if I fill up 3 and 5 there, it means I can find the other side, which I'll call y for now, by simply using the Pythagoras theorem. So part of the marks that you see here in the first questions always include the Pythagoras theorem. So I'm going to say, okay, to find my y, I basically say y squared is equal to, or maybe let me start by saying 5 squared as the hypotenuse is equal to y squared plus 3 squared. And then I give a reason in bracket. I say Pythagoras theorem. This is going to count for marks. Pythagoras theorem. Okay, then I can solve for y, and it just be simple from there. Y will basically be the square root of 5 squared minus 3 squared, which is 25 minus 9, and that will give you 16. The square root of 16 is 4, or plus minus 4. So y becomes plus minus 4. But then we go in and check our quadrant. It's the first quadrant, which means literally everything is positive, guys, in the first quadrant. So I choose the positive answer. So I say y is positive 4 because we are in the first quadrant. So this value here is positive 4. Then I can go and answer the question, but this Pythagoras theorem will form part of 3.1.1. But then 3.1.1 specifically asks me to find tan theta. Tan theta from SOHCAHTOA is defined as opposite over adjacent. Then my opposite side, you'll all agree, is 4. My adjacent side is 3. So to answer the first question, tan theta is equal to 4/3. So you can see here the first 2 marks will basically come from the Pythagoras, and the last mark will come from actually answering the question. So 3 marks in total for that. Pretty simple and straightforward. But if you have a question, just click on the raise your hand button. If you don't see the raise your hand button, just click on the middle of your screen and then it will pop up. It shows a hand. Okay, 3.1.2. What about sine 2 theta? Okay, sine 2 theta. I already know all the sides on my triangle, so this shouldn't be a problem. How can I find sine 2 theta? Recognize that this guy is an identity, or we have an identity that we discussed for a double angle. If you have an angle that is multiplied by 2, we call that a double angle identity. So if you go down to your formula sheet at the back of your question papers, for me, I put it up top here, and it's the thing that we discussed before we started the lesson. And then it basically says, if I have the sine of a double angle, that will be changed to 2 multiplied by the sine of the angle multiplied by cos of the angle. So I'm going to change sine 2 theta and make it 2 sine theta multiplied by cos theta. Let me do that right now. So sine 2 theta is basically equal to 2 sine theta multiplied by cos theta. That's what the identity says at the back of the question paper. I don't even have to cram this. It's written for me. Then I say, okay, 2 multiplied by sine theta. Go back to your triangle. Go back to SOHCAHTOA. What is sine? Sine is opposite over hypotenuse. So my opposite to theta there is 4. That's the side initially labeled y, which we find 4 by Pythagoras. So I'm going to have 4 over hypotenuse is 5. So here on top it's just 4 over 5 for sine theta multiplied by cos theta. What is cos theta from our triangle? Cos theta is 3 over 5 adjacent over hypotenuse. It was also initially given to us, so 3 over 5. Then from there I just need to multiply the top and the bottom. So I'll start with 2 multiplied by 4. That will give me 8. 8 multiplied by 3. How much is that? 8 by 3. Anyone with a calculator nearby?
4.
24. Okay, thank you. 24 over 5 multiplied by 5. I think that one is 25. So this is the final answer, 24 over 25. I can't simplify it further. That's how far it can go. No need to show the decimal in this case. Remember, they expect you not to use a calculator. But if you check here, you can actually multiply that bracket out using a calculator. So that's the point, or that's the only area where you can use a calculator. You see, you don't have to stress about this part. You can just multiply things in a calculator there and then write your final answer. Okay, so 24 over 25, how they are going to mark this? They'll mark you for writing the correct identity. They'll mark you for the correct substitutions, and so the final answer. So in total here you'll get 3 marks. It's very important to know where you're going to get your marks so that you don't actually waste your time doing things that don't actually count for marks. Okay, then the last question on this 3.1 is determine the value of k. Okay, for most of you, for sure, this one is like a shocker, because usually they'll ask you the sine, the cos, the tan of something, but now they want k, and k was given as the x coordinate of r. So how are we actually finding that one? Let's look at how we can actually plan this. So in maths, you should always have a plan of how you're going to solve any question. We have a situation whereby this line, let me just highlight it. This line that has point R is perpendicular to this line that has point P. Our minds are wired differently, but whenever I see perpendicular, I think of the gradients. And in analytical geometry, you remember from grade 11, lines that are perpendicular to each other, if I multiply the gradients, I get how much? Who remembers? If I multiply the gradients of parallel lines, what do I get?
-1.
Get what?
-1.
-1 actually. So just remember it's negative 1. If you say 1, then it's a little bit wrong. So it's negative 1 that I should get. So if I just find the gradient of point P, I mean the gradient of the line that connects P, I can actually find the gradient of the line that connects R by multiplying that by negative 1. And so since I have the Y value, I can also use that to find the X value. So I am basically solving for the equation of a line. And this is not the only method. So we'll see how many methods we can use. But as for me, thinking about this, that is the easiest way I can actually do it. So I'll say the gradient of the line that connects P, I'll just call it MP, multiply by the gradient of a line that connects R, I'll call it MR, should always give me negative 1 since they're perpendicular to each other. So now I need to find the gradient of MP. And I already know the tan of theta. Remember from analytical geometry, the gradient of any line is equal to tan theta, which is the angle of elevation of that line, or inclination, I think that's what they call it. So MP is equal to tan theta, which means MP is equal to tan theta was shown to be, I think, 4/3, yes, from our 3.1.1, 4/3. So if I take 4/3 and I multiply by MR, I'm supposed to get negative 1. So let me put it back in that equation. 4/3 multiplied by MR should give me negative 1. So MR will then be how much? Negative something. What will be the value? Anyone who's quick with a calculator, I'll really appreciate your help today.
Negative 7/3.
Okay, I think maybe you add it, but how we solve this from here is we actually divide both sides by 4/3 so that we can take out this 4/3 and this side also divide by 4/3. So it's not gonna be 7/3. Negative 3/4. That is correct. Okay, so just make sure mathematically you divide correctly. So negative 3/4 is the gradient. Okay, for MR, right? Therefore, now that I know the gradient of MR, look at how the graph, the straight line graph of MR or of the line connecting R looks. It crosses right on 0. So if I can write the equation of the straight line as y is equal to mx plus c. What is the value of c in that case? Knowing that the line actually crosses 0 like this. If I continue, it's going to look like this. What will be the value of c? C is 0, guys. Remember, c is the y-intercept. And the y-intercept here is exactly 0 because the line crosses at 0. If the line was crossing at -1, then the c value will be -1. But in this case, it crosses right on 0, so c is 0. So I can basically go and say, okay, my c value is 0. So I'm basically left with y equal to mx, and I know the value of my m is just negative 3/4 multiplied by x. Then I go to the r coordinate, which was located somewhere here. It was saying k and 6. And I know that the first value, the first entry is the x. The second entry is the y. So if I substitute that r coordinate, let me write it for you. Substitute r is k and 6 into y equal to negative 3/4 x. Then I'm going to have 6 for y, negative 3/4 multiplied by k for x. Then I'm trying to solve for k, remember? So I literally just need to divide both sides. Don't even stress, guys. Don't even say we are multiplying by 4 and we dividing by -3, blah, blah, blah. Just go ahead and divide by the thing that you don't want on the other side. So divide by 3 over 4, negative 3 over 4, that cancels that. And then this side we can see what answer we get. What do we get?
-8.
Negative 8. There we go. That's what we're looking for. Just the final answer. So K is equal to negative 8. So go ahead and check if that makes sense. K is in the second quadrant, and that side, the X values are negative. So to me, that makes a lot of sense. And that will be the final answer for this question. It was 5 marks. So I'm thinking they'll give you a mark for doing this relation, and they'll give you a mark for saying the gradient is 4 over 3. And then I guess the gradient of MR will also be worth a mark. And either the equation or the substitution, somewhere they will get a mark, and then the final answer as well. So in total, 5 marks for this question. Okay, if you have a question, don't even wait, just raise up your hand. And yes, Hachana, can go ahead.
So you see, sir, I did not understand when you explained the C part.
The C part. Oh, okay. So for an equation, how do you normally find the equation of a straight line? What do you do for yourself? How do you usually find the equation of a straight line? Let's say it's a question.
By substituting any point on the graph, sir.
Yes.
Oh, I look for
Yes.
the right.
Okay. Basically there's 2 ways you can do this. There's an equation that says y minus y1 equal to m into x minus x1. But literally, for you to find an equation of a straight line, you need a point. So point whereby the line touches, and a gradient of that line. So we know the gradient, it's m. Now we need a point whereby that line touches. And using this equation is fine. You can just say y minus 6, which is the point that we have there. The gradient is negative 3 over 4. And then we have x minus x1, and x1 is k, I think. Yes, and then you can solve and see what the equation becomes. I think this will be a little bit difficult for you to actually solve, because you'll then need another point basically. Oh, actually, here's the point that you can actually have. Since the graph, look at the graph that we have here in the beginning. Let me remove the yellow highlighter. There's another point that the graph actually touches. The line that connects R is actually touching 0. And that's mainly the point whereby I say C is 0, but I'll repeat that again. Then let's say we use that point actually to substitute our y1 and x1. So I use 0 for y1 and I use 0 for x1, because the coordinate there at the center is 0 for x, 0 for y. And then this side I'm left with y equal to negative 3 over 4. And then this side I'm left with x. And that's the equation of the straight line. But if I want to use y equal to mx plus c, then I'll have to do the same. I'll have to find c by substituting this coordinate 0 and 0. So 0 for y, 0 for x, plus c. And m times 0 just becomes 0, so c equal to 0. You can prove it that way by substituting the 0 coordinate, or just by observing the fact that the graph cuts on 0. The graph cuts the y-axis on 0. It means the y-intercept, this is defined as the y-intercept, is also 0. If the graph cuts 0 for y, it means the y-intercept is 0. So that was why I said the y-intercept is 0. But you can also use the coordinates 0 and 0 to actually prove that point. I don't know if that answers your question.
Yes, it does. Thank you so much.
All right, thank you. Then we move on to 3.2. Let's see what it says. Simplify fully. So let me go and just rewrite this, and then I'll copy it and put it on a fresh page. So you're just trying to simplify this expression. From where I'm sitting, it looks to be scary, but let's see what we can do with it. Sine 35 degrees minus beta plus sine 25 degrees plus beta multiply by sine 55 degrees plus beta. Okay, then I'll go and just cut that. Then I'll put it on a fresh page. So we are simplifying here in this case. Let me remove that. Okay, looks like we need to move faster a little bit just due to time. So let me make more room. Okay, so simplify this expression for 3.2. So looking at this, what you should do is to actually have a plan of what to actually, or how to actually approach this question. And just by observing it, guys, you should already tell that this thing looks to be a grade 12 identity. Look at it. It looks to be, I mean, it's not exactly, but it looks to be cos alpha sine alpha plus sine alpha sine beta. Sorry, I put alpha there, but let me put beta. Just mainly because I have a trig ratio there, a plus in the middle, another trig ratio, another trig ratio. So this looks exactly like something that will look more like this, which I have here on the formula sheet. Either of those four. How I'll see which one it is, I'll just check. I'll just change things around and see which one it is. So let's go ahead and see how to actually solve this question. But in your mind, you're supposed to see that I'm going to end up with something like that. So you work your way towards it. So always manipulate things towards something that you can actually understand in mathematics. So cos 385 plus beta, already I can see that I need to use the reduction formula. And because 385 is bigger than 360, I can just say, okay, this is cos into 360 plus something. I don't want to change anything that is within this bracket. So whatever I do here should exactly be the same as what I have in the initial bracket. But I can break 385 into 360 plus 25. If you look at this, 25 degrees. And then I can go ahead and add my beta after that. Then I didn't change anything. You can see 385 is still 360 plus 25. But now what's interesting is that this thing, which I'll put in a red bracket, is actually my reduction or my acute angle that I'm going to reduce this bigger angle with. So just put this into bracket like that and then close my main bracket. Multiply by sine. This one I'll just leave alone for now. I'll see if I need to change or anything, but I'll leave it like this for now. And then plus sine 25 degrees plus beta. So the rest I'm just going to leave alone. Sine 55 degrees plus beta. Okay, then cos 360 plus some angle is the same as just trying to reduce cos 360 plus theta. And if we go to the reduction formula, you'll see that 360 plus any angle will actually take that into the first quadrant. That's 360 plus any angle. It will take you to the first quadrant. And in the first quadrant, everything is positive. We don't even have to ask. So our cosine here will be positive. So I'm going to end up with cos this angle in red, 25 degrees plus beta. And then now I look at this the whole thing now, I can see, okay, 25 plus beta, that seems to be matching with this 25 plus beta. So that's good. That's what I'm looking for. But then this other bracket, 35 minus beta, it is not matching with the 55 plus beta. So what can I do? I can actually change this one into a co-function. How about I do that? So it's just you trying things out. I can change sine of any angle, sine theta, into, look at this for co-functions, sine theta can become cos 90 minus theta. Look at that co-function there. So a positive sine can become a positive cos of 90 minus that angle. So I'm going to use that co-function. Therefore, I'm going to say, okay, sine theta is equal to cos 90 degrees minus this angle theta. So for this case, it's going to be cos into 90 degrees minus this angle. I'm going to use red again so that you see the main angle, 35 degrees minus beta. Maybe I also write it in red. So let me also change this and write it in red. Okay, very good. So I close the bracket now, and then I write everything else the same way it was. Sine 25 degrees plus beta multiply by sine 55 degrees plus beta. Okay, then going down, this one I still keep because it looks to be something that I'm gonna use. 25 degrees plus beta multiply by cos. Now 90 minus into 35 minus beta, this becomes 90 minus 35 minus multiply by minus becomes plus beta. So 90 minus 35 becomes 55, and then plus this beta. So that's what I reduce this thing to become, 55 plus beta. So I'm gonna write that in my bracket. So multiply by cos 55 degrees plus beta, and then everything else, once again, I keep them the same way they are. 25 degrees plus beta multiply by sine of 55 degrees plus beta. And now look at this. This is exactly what I wanted. 25 degrees plus beta, 25 degrees plus beta. So that looks good. And then once again, 55 degrees plus beta, 55 degrees plus beta. So this looks to be an identity that I did in grade 12. So cos of something multiplied by cos of another thing plus sine of something multiplied by sine of another thing. That looks to me like this identity. Once again, you go to your formula sheet, you'll find this identity is given to you. But to me, this looks to be this compound angle identity. Cos of something minus something is equal to cos of the first thing, cos of the second thing, plus sine of the first thing, sine of the second thing. So basically I can change this whole thing here to equal to, it's a cosine compound angle with a negative in between, because right here you see a positive, so in between should be a negative. Okay, so it's cosine into, the first thing here is 25 degrees plus beta minus the second thing is 55 degrees plus beta, close bracket. So I just had alpha for this minus beta for that. If this guy is alpha, this guy is beta. So I think that makes sense to you all. If it doesn't, then just let me know. I'll re-explain it to you. Then I can continue and say, okay, cos 25 degrees plus beta minus 55 degrees minus beta. Therefore, the betas are going to cancel out. and we are left with 25 minus 55. 25 minus 55 is negative 30 degrees. So now we go back to reduction and we say, okay, negative angle falls under the fourth quadrant, and in the fourth quadrant cosine is positive, so cosine of a negative angle will become positive. So I can right away go and say, okay, this is positive cosine 30, because cosine of a negative angle is a positive cosine. Therefore, I also recognize that 30 degrees is a special angle. And right here, once again, this is where you can use a calculator, just because it's just going to give you, but it shouldn't give you an answer in commas, it should give you an answer in fractions. If you don't trust your calculator to give you an answer in fractions, you can always remember your special angles, 30 degrees, 60 degrees. Then this will be 1, this will be 2, and this will be, I think, square root of, is it 3? Yeah, I think it's square root of 3. Then cosine of 30 will then be square root of 3 over 2, which is adjacent over hypotenuse. And that will be your final answer. You're not really done. You're supposed to check your answer if it's actually correct. How do you actually do that? So listen up, everyone. To check your answer if it's actually correct, you go to your original question and you say, I can actually take any value of beta and substitute it there for every beta, and then I go and press that in my calculator. It's supposed to give me square root of 3 over 2 at the end if I did everything correctly. If it doesn't give me that, then I made a mistake somewhere. So what is any ugly number that anyone can think about that we can use as beta, and then we can substitute that in our calculator to check our answer? Any number that is actually kind of ugly, because if you use a beautiful number, then you might find out that the answer is correct, but just by coincidence. So any ugly number, anyone? Any number we can use for beta?
Negative 7 over 3.
Okay, negative 7 over 3, that's fine. It looks like something that won't be an angle, but it's fine. Usually we want something that looks like an angle, but that's okay. Let's test that. Times sine of 35 degrees. So usually we'll use a degrees, like maybe say 55 degrees or whatever, but literally any number is supposed to work. Okay, so that will just take me a brief second to substitute. Plus sine of 25 plus into negative 7 over 3, so I'll just put a negative 7 over 3. Thank you for that, Cabello. 7 over 3, and then the last one is multiplied by sine 55 minus also 7 over 3. Okay, so that is our chosen beta value, and final answer, it's 0.8660. So just remember that value, 0.8660. Then you go and say, okay, is 0.8660 the same as square root of 3 over 2? Those who have calculators,
Yes,
for
it
sure.
is.
Yes, it is. So that way you already proved yourself that, okay, I'm getting all the full marks for this question. That's the beauty of mathematics. You can always mark yourself in the test. Okay, this question itself was like 4 marks, so it's not a lot for the kind of work that you actually have to do, but they'll mark you basically where you are changing things. So literally where you changed this thing into an identity, that will definitely be worth a mark. Where you change this reduction from negative to positive, definitely worth a mark, and your final answer is worth a mark. So the other mark, I'm guessing it will come from somewhere here. So 4 marks in total for that. Okay, if you have any question, you can go ahead and raise up your hand to ask. If there's no question, then we move on. 3.3, we have this sine 3 theta, so I'm just going to copy it right here, and then I'll take it to a new page where we can start to solve, is equal to 4 sine theta multiplied by cos squared theta minus sine theta. The first question is to prove the identity for 5 marks. So prove that the left hand side is equal to the right hand side. How do we do those questions? Let me make a new page. Okay, that is 3.1, I think. So 3.3.1. We want to prove that the right hand side is equal to the left hand side. Okay, whenever you are proving something, you're supposed to pick one side that you want to work with to show that it's actually exactly the same as the other side. And then looking at this, I see we have 3 times an angle. And then in my mind, you see, in maths, you are working ahead of yourself. Don't work behind yourself. Think about what you're going to find ahead. So what I see right now is that 3 theta looks to me like I can get something like sine 2 theta, which will be a double angle. So I'm going to work with that side and try to prove it to be the other side. I could choose the other side to work with, but looking at this, I think 3 theta will make some world of magic for me. So I'm going to choose the left hand side to work with, and the left hand side is equal to sine 3 theta, and I can change 3 theta to become sine of 2 theta, which is the double angle, plus theta. That is already the same as 3 theta, isn't it? So 2 theta plus theta is the same as 3 theta. And then look at what we just did. This is a compound angle identity. So I go to my identities at the back of my question paper. For me, it's up top here. And then I can see that this is this identity. I just need to make my alpha 2 theta and make my beta theta. So I'm going to have sine theta, sine 2 theta cos theta plus cos 2 theta sine theta. Okay, so that's an identity itself. So I'm going to say, okay, this is sine 2 theta cos theta plus cos 2 theta sine theta. That's what the identity says. Okay, then once again, I recognize that this is a double angle identity. So trigonometry question 3 is always a game of identities. Those two are identities. And then I say, okay, for sine 2 theta, that's the one that doesn't change. It's the one that remains the same, this one that I highlighted here already. So I change that into 2 sine theta and cos theta. Okay, let me go ahead and do that. So sine 2 theta changes to be, I'll actually use a different color pen for you to actually see that when you revise. Oops, let me go back here. So this will be equal to 2 sine theta, because it's double angle, multiplied by cos theta. And then this is multiplied by this cos theta plus, and then cos 2 theta is an identity itself. And that's the one whereby you have to be smart about it. You have 3 options to choose. Here's cos 2 theta, just going to change alpha into theta. And you have 3 options to choose from. And you kind of have to think about it. Okay, I'm trying to make this thing become, I'm trying to make this whole thing here become this thing. So which identity will be the smartest to choose? And anyone can try. I can wait for someone to give me an answer, but I already can tell which one will be easier to use. Anyone who can give it a try, which identity can you choose?
1 minus 2 sine squared theta.
Okay, 1 minus 2 sine squared theta. Let me go to the identities. 1 minus 2 sine squared theta. Okay, then going back to this, how will that one help me? So I'm going to check. Let me just put it in first. 1 minus 2 sine square theta, multiply this by sine theta. Okay, it looks to be there's going to be sine. If I multiply this and this, there's going to be sine 3 theta, and that could be problematic because we don't have sine 3 theta somewhere here. So I'll say that option might end up being longer. So let's choose a different option. Let me go back to the identities. Let's choose a different option. Which one? Okay, I'm sure people are just scared to say, but this one should probably work very well for us, because the cos squared theta is always there somewhere. So I think that would be the smartest choice for you. So I'm going to put the double angle as, I'll also use a different color for this one, 2 cos squared theta minus 1, and then multiply this by the sine theta that is always there. Then now I can solve. This is equal to 2 sine theta, cos theta multiplied by cos theta is cos squared theta, plus 2 cos theta multiplied by sine theta, that becomes 2 sine theta multiplied by cos squared theta, and then minus 1 multiplied by sine theta becomes minus sine theta. Let me know if there's a mistake or if there's something you don't understand me multiplying this bracket with that. Yes, Mikongelo, you agree with everything, or do you have a question?
No, I agree.
All right, that's good. Then you can see that 2 sine theta multiplied by cos squared theta and 2 sine theta multiplied by cos squared theta is basically a like term. It's the same thing. It's like 2x multiplied by, plus 2x. So we can add this to become 4x. So if I add this 2, it becomes 4 sine theta multiplied by cos squared theta, and then the other side is just negative sine theta. And you can see that definitely that is exactly the same as the right hand side. So I'll go and conclude this is equal to the right hand side, and I'm done. That's my I think 6 marks or 5. I think it is 5. Yes, that's my 5 marks in the bag, just like that. Okay, any questions? So that's why I say the choice of a double angle for theta, for cos 2 theta, is very important. You have to really be smart on that one. If you choose a wrong one, there's no wrong one, but I'm using the word wrong to say one that is not actually going to help you out. You're gonna run into problems. So just look ahead to say, if I have cos squared theta there, it means I need to choose one with cos squared theta. If I choose one with sine squared theta, I'm gonna run into major problems. Okay, so there we go for that one. 5 marks. How they are going to mark is basically everywhere this where you put changes is going to be worth a mark, because trigonometry is a game of identities. So here we put up an identity, so we get a mark for that. These two are identities, so we get a marks for those. And then I'm guessing adding the two values also is worth a mark, and maybe separating this will also be worth a mark. So 5 marks in total is pretty generous if you ask me. Okay, there's probably a lot of other ways you can do this, but this will be, in my opinion, the easiest. Okay, then let's move on to 3.3.2. Hence or otherwise, prove the following identity. Hence or otherwise, prove the following identity. Key word for you is the word hence or otherwise. Whenever you see the word hence or otherwise, it means you should probably use the answer that you just found to help you out to solve the other question that follows. So we're supposed to prove the identity that says sine 3 theta plus sine theta divide by 2 plus 2 cos 2 theta is equal to sine theta. But because of the word hence or otherwise, it means we should probably include something that we learned previously to help us to solve that question. So let's see how we're supposed to do this one. 3.3.2. So 3.3.2. Hence or otherwise, prove this one. Okay, immediately when I look at this, guys, I see that on the left hand side I have sine 3 theta, and I already proved that to be something. I already proved that to be something else. So I'm going to attack that first. But first I need to write out the left hand side fully, and then I'll say, okay, sine 3 theta, which I'll highlight right here, is equal to this guy right here. I just proved that identity. That's why they say hence or otherwise. It's equal to that guy right there. So I'm going to put that as that. So this is equal to, I'll write this in a different color, 4 sine theta multiplied by cos squared theta minus sine theta. That is sine 3 theta alone. And then I'm having plus sine theta going forward. And then I'm dividing all this by 2 plus 2 cos 2 theta. And you can already tell that that's a double angle identity. So we can as well change it into what it will become. And once again, because it's a cos double angle, we have to be smart about it. Okay, so then I'm going to put down 2 plus 2 open bracket, and then I say, okay, how can I solve this cos double angle? Which identity will be the smartest to use? First one, second one, or third one? Okay, if you ask me, I'm thinking the third one, once again, will probably be the smartest to use. Why? Because I see cos squared alpha, and indeed on top I have cos squared alpha. So those, I'm sorry, theta in this case, so those might cancel or do some things for me. So that's why that will influence my choice. So it's always thinking ahead. If it doesn't work out, you don't jump the question, you try another one. Okay, so you try one of those other 3 or 2. So I'm gonna use now 2 cos squared theta minus 1, and then I proceed. Going forward, you see that negative sine theta and positive sine theta are going to cancel. So I'm basically left with on top 4 sine theta multiplied by cos squared theta. On the bottom I have 2 plus 2 times 2 is 4 cos squared theta, and 2 multiplied by negative 1 on the other end is going to be negative 2. Therefore, you can clearly see that the 2 and the negative 2 are going to cancel. So I'm left with 4 sine theta multiplied by cos squared theta over 4 cos squared theta. Therefore, we can see the 4 cancels the 4, the cos squared theta cancels the cos squared theta, and then I'm left with sine theta. This is all equal to sine theta, and basically I just proved the identity. It should be equal to sine theta, and I can conclude by saying this is equal to the right hand side. There we go. Very nice. Mikongelo approves. Okay, we can see how they are going to mark. Once again, it will be basically where there are changes. So I'm thinking those places, and also somewhere along the lines of those other steps. Then you have 3 marks total. Okay, very nice, isn't it? 2 proving questions. Both of them looks to be doable. Okay, remember I always say if you have a question of your own, you can always send it down in the group, and then in one of these lessons we'll actually look at it. There's always those questions whereby you think, hey, this one I can't solve. Okay, then next we have determine all values of theta for which the identity will be undefined. So I'm thinking they are talking about that identity. So which values of theta will that identity be undefined? Oh yes, they did say question 3.3.2. Okay, so let's look at that identity and think about where will it be undefined. So let me go and make up space for 3.3.3 undefined. What is undefined? Undefined is whenever you are dividing by 0. So this means division by 0. Division by 0. You don't have a solution whenever you're dividing by 0. So if I look at my identity here, how can this be divided by 0? Can this side be divided by 0? No, there's nothing on the bottom. Can this other side be divided by 0? Yes, because there's something on the bottom. So this guy on the bottom, if it becomes 0, then my whole thing here is undefined. So that's what they wanted to solve. So solve for the values of theta whereby this whole thing in green will be 0. So basically I'll go and say 2 plus 2. I'll go and say 2 plus 2 cos 2 theta is 0 for the whole thing to be undefined. That should make sense. If it doesn't make sense, please ask me to re-explain. Don't be scared. Then if it should be 0, it means I need to take the 2 to the other side. I'm basically just solving for x or theta. So I'm going to have 2 cos 2 theta is equal to -2. Then I can divide by 2 both sides. So cos 2 theta is equal to -2 over 2 is just -1. And if you go and look at this, this is where we start to see that, oh boy, we are actually doing a general solution question. This is actually a general solution. So how do we solve general solutions? Right, let's go ahead and see. After we express our equation in this form, so that we have a trig ratio equal to a specific number, we go and calculate a reference angle. So step 1 from there, calculate the reference angle. How do we do reference angle? Guys, when you do a reference angle, you forget about the sign of this number, whether it's positive or negative. Forget about that. Go ahead and just solve for the angle without the negatives. So I'm going to say reference angle is equal to cosine -1 into 1. And then what do we get for that when we do cosine -1? I mean the second function of cos of 1.
We get 0.
We get 0. So our reference angle is basically 0. Therefore, step number 2 for general solution, to work for any general solution question, we'll see another general solution soon. So step 2 is you're going to check let me just say check the we call them quadrants, the quadrants for which the main trig ratio is negative. Basically, I don't know how to put that in words, but you see here cos 2 theta is negative. So you go to your quadrants and say, okay, where is cos theta negative? So let me draw a quick Cartesian plane here, and we're going to think, all of us, where is cos theta negative? It's a cast diagram, oops, which means C A S T, and this is all for the first quadrant. The second quadrant, it's only sine that is positive. Third quadrant, it's only tan that is positive. Fourth quadrant, it's only cos that is positive. So quadrant 1 and 4, cos is positive, but we are looking for quadrants where cos is negative. So that will give us the third quadrant, the second quadrant and the third quadrant. So we go and say, okay, this is the second quadrant and third quadrant. So I'm going to say whatever I see inside as an angle 2 theta is equal to, second quadrant, guys, says to us 180 plus theta. Remember reduction formula, 180 minus theta for the second quadrant. The third quadrant, 180 plus theta. So we go and use those quadrants and say, okay, for the second quadrant, I have whatever is inside. In this case, it's 2 theta inside. It could be theta, it could be x or anything, but whatever is inside is equal to 180 degrees minus the reference angle that I found. And the reference angle in this case is 0. So 180 degrees minus 0 is basically just 180 degrees. And then we're going to add, because it's general solution, we're going to add k multiplied by 360 degrees, which is the overall period for a cosine graph. Then this k is actually the element of integers. Integers are just whole numbers, like the whole numbers that you see on a number line, from the negatives all the way to the positives and so up to infinity. That's what we call integers. Remember, this which I just did here is only in the second quadrant. In the third quadrant, I'm going to do the same. So let me write second quadrant here. In the third quadrant, I'm going to do the same. I'm looking for places whereby cos is negative, because I get a negative 1 there on top. So let me take this and make it smaller. Then I go to quadrant 3. And then I'm going to do the same. I'm just going to copy and paste this thing. But remember, quadrant 3 is 180 plus that reference angle. Okay, so I put that there. And showing them that k is the element of integers, so you can only just show on the other end there. But it's very important. You see, if you don't tell them that k is the element of integers, then you get, or you lose a mark automatically, because you are adding something that we don't know and you don't tell us what it actually means. So you should always say k is the element of integers. You don't really have to only use k, you can use n or just any value. Okay, then third quadrant once again is plus 180 plus, and the reference angle is 0, guys. So it turns out that if it's 0, 180 minus 0 is just 180, and 180 plus 0 is just 180. So this all becomes the same thing. 2 theta is equal to 180 degrees plus k multiplied by 360 degrees. And if I divide all the way through by 2, I get 90 degrees plus k. 360 divided by 2 is 180 degrees. And you already told them what k is, but you can do it again. K is the element of integers. And that's the final answer, ladies and gentlemen. So we just found the values of theta for which this whole thing is undefined. So you see, the question didn't really specify for you to calculate the general solution, but as you go on, you see that, oh, these guys are actually asking me for the general solution. Okay, and there we go. We just solved this question. Any questions? These are integers, by the way, which is shown by the letter Z. It's not really a Z, it's a Z with a double line in between. So just make sure you use the correct notation. All right, so that is that. If you have a question, raise up your hand. Let's see what will be the last question on this is determine the minimum value of cos 3x minus 5. Oh, by the way, how are they probably going to mark this? I'm not sure, but I'm thinking maybe you get 1 mark here, and then you get 1 mark for the reference angle, and you get the other 2 marks from doing your quadrant, and so the final answer. So 4 marks in total here. 3.4 I think here. 3.4 is minimum value of cos 3x minus 5. What is the minimum? What is the lowest point that value will ever get is the question. Okay, it's a very, very simple question, this one, if you ask me. What you need to do to see it is to think about trig function for cos, and any cos function will go from there, which is 1, all the way to -1, as long as the amplitude is 1, and the amplitude sits at the beginning. So if there's no number here, it means the amplitude is 1. So literally the lowest value you can ever reach is -1 for this cosine graph. If it was 2 cosine 3x, so the lowest point you'll ever reach is -2. So the graph will go like this. Okay. The 3x only affects the period. I'm sure most of you know this. So that will only affect the period, not the lowest point and the highest point. So the lowest point the graph will ever reach is literally -1. So I'm going to say the minimum of this whole thing is -1. And I have -5, so I'm just taking this down by 5 units. So if it was the graph itself and it was sitting like this initially, I just need to take it 5 units down. So I take it 1, 2, 3, 4, 5. So where is it sitting if I take it 5 units down? It's sitting at -6. Or I just literally have to take -1 minus 5, and that gives me -6. -6. And that's the minimum. So you get a mark for that, you get a mark for that. 2 marks in total. Pretty simple. Looks like a give and go for me. But you have to understand the basics of trig functions. Okay, so that's the minimum of cos 3x minus 5.